Imagine a world where skyscrapers rose without steel, or flight existed before the Wright brothers. Now picture this. Civilizations from thousands of years ago, engineering water systems so complex, they defy our modern understanding. How did they move rivers, create underground aqueducts, and manage citywide water distribution with such incredible precision? All without the tools we deem absolutely essential today? Forget everything you think you know about ancient technology. We're about to uncover engineering marvels so far ahead of their time, they make our modern achievements look like child's play. We're talking about systems that are, by all accounts, impossible. From the hidden tunnels beneath deserts to the intricate plumbing of cities carved into mountainsides, we'll reveal how these societies somehow mastered hydraulics thousands of years before the accepted timeline of innovation. Prepare to have your mind blown. I've spent years researching ancient civilizations, and even I was stunned by what I found. There are hidden water systems, some still functioning today, that reveal a level of hydraulic engineering we simply shouldn't expect from these periods. Join me as we journey back in time, not just to admire these incredible structures, but to question everything we thought we knew about the ancient world's true capabilities. This isn't just a history lesson, it's a deep dive into the unknown. Everyone knows the Roman aqueducts. These monumental arches, marching across the landscape like a stone army, are symbols of Roman power and engineering genius. But here's a secret: they're not the full story. In fact, if you only look at the aqueducts, you're missing the true heart of Rome's hydraulic mastery. The real secret weapon wasn't what they built above ground, but what they perfected below it. While the aqueducts were the veins carrying water to the city, the real magic happened in the hidden, intricate systems that managed that water once it arrived. This included massive urban fountains, complex public baths, and, perhaps most impressively, a vast and ingenious system of sewage and drainage. We're talking about an entire city designed to be flushed clean, something that wouldn't be seen again on this scale for over 1,000 years. The Romans understood something fundamental. Water management wasn't just about bringing water in, it was about getting the waste out. They treated sanitation as a public priority, and in doing so, they created something truly revolutionary. So how did they do it? Let's take a deep dive into the specifics. First, consider their understanding of gravity. Roman engineers were masters of surveying. Using simple tools like the chorobates, a type of level, they could calculate a precise, continuous, and unbelievably shallow gradient for their aqueducts and underground pipes. We're talking drops of just a few inches over a mile, a precision that even modern engineers find staggering. This allowed them to transport water across vast distances using only the power of gravity, without the need for pumps or modern machinery. Next, their material science was revolutionary. To build the aqueducts and pipes, they used a concrete that was unlike anything before or since. They mixed volcanic ash, or pozzolana, with lime and water. This special mixture not only hardened underwater, but actually became stronger over time. That's why so many of their structures, from the massive foundations of the Colosseum to the intricate pipes buried for centuries, are still standing. This waterproof cement allowed them to build structures that were both immense and impervious to the constant flow of water. But the real mind-bender is their use of siphons. An aqueduct could carry water across a valley on massive arches, but sometimes the valley was simply too deep or too long. The Roman solution was a lead pipe siphon. They would build a large lead pipe, sometimes as thick as a tree trunk, down one side of the valley and back up the other. The immense pressure at the bottom of the valley created by the descending water would force the water back up to the other side. This was a sophisticated application of physics and hydraulics that required perfect craftsmanship to withstand the pressure, a concept we associate with far more advanced periods of history. And it wasn't just about the pipes. The Roman baths, like the famous baths of Caracalla, were a testament to their hydraulic prowess. They had systems for heating the water, for regulating its flow, and for distributing it into dozens of different pools. They were, in essence, the world's first large-scale public plumbing systems. These were not just functional structures, they were social hubs, centers of commerce, and showcases of Roman power. These engineering marvels fundamentally transformed Roman society. With access to clean, flowing water, Roman cities could grow to unprecedented sizes. The threat of disease from poor sanitation was dramatically reduced. The public baths created a sense of community, and the fountains provided fresh water to everyone. This mastery of water was not just a convenience, it was a cornerstone of their civilization. It enabled their population to thrive, their economy to flourish, and their empire to grow. So the next time you see a Roman aqueduct, remember the hidden genius beneath its arches. Remember the siphons that defied gravity, the concrete that grew stronger with time, and the belief that every citizen deserved access to clean water. Their legacy reminds us that true innovation isn't just about power and scale, but about understanding the very forces of nature and applying them to build a better world for everyone. We've just explored how the Romans conquered valleys and plains. But now, let's move to a completely different world, a world of treacherous mountain peaks and deep ravines. Here, amidst the rugged Andes, another civilization faced an impossible challenge. They didn't just need to channel water across steep terrain. They had to figure out how to sustain life at altitudes where almost no other civilization dared to live. The Inca, with their extraordinary ingenuity, didn't fight nature. Instead, they worked with it. They didn't build monumental aqueducts to bridge valleys. Instead, they created a complex liquid labyrinth, a hidden network built into the very stone, not just to supply water, but to nourish a vast empire under the harshest conditions. To truly understand the genius of the Inca, we have to look at what they did with the earth itself. They created massive terraced fields, or andenes, that hugged the mountainsides. These terraces didn't just prevent erosion, they were an integral part of their hydraulic system. Each terrace was designed with its own drainage canal and a permeable base layer that retained essential moisture for crops while draining away excess water to the next level down. It was an automated irrigation and drainage system, built thousands of years ago. But that was just the beginning. Look at their stonework. Every single stone, perfectly cut and shaped, didn't just fit together. It formed channels and grooves for water. The Inca didn't use mortar. They used a technique called ashlar masonry, which allowed them to create water paths that were not only incredibly durable, but also astonishingly precise. They built intricate waterways that channeled water from high-altitude springs down into villages and cities below. And we can't talk about Inca water without talking about Machu Picchu. This lost city is not just an architectural marvel, it's a hydraulic masterpiece. The city was built around a natural spring on the mountaintop, and the Inca turned that spring into the city's lifeline. A primary channel, running for nearly 740 meters, fed water to 16 intricately carved stone fountains. Each fountain was strategically placed to serve a different area of the city. The truly incredible part is that the flow of water through these fountains was perfectly controlled. By carefully adjusting the slope and width of the channels, they could regulate the water's flow, ensuring that everyone, from common citizens to royalty, had access to clean, fresh water. Their drainage system was just as impressive. Terraces, side channels, and vents were integrated into the entire structure, ensuring that rainwater never accumulated, keeping the entire mountain city stable for centuries. For the Inca, water was not just a resource, it was life itself, a sacred symbol. The canals and fountains found in their ceremonial sites weren't just for providing water for rituals, they were part of the ritual. They believed that water brought purification and a connection to the gods. These structures were built not just with intelligence, but with reverence. And this holds an invaluable lesson for us today. In an era where we're grappling with climate change and water scarcity, the sustainable solutions of the Inca provide profound insights. They prove that combining engineering with a deep respect for nature is not only possible, but it's the path to long-term prosperity. They taught us that instead of conquering nature, we should learn to work with it. The Inca's liquid labyrinth is not a marvel of defiance, but a marvel of harmony. And these ruins, which still stand today, are a powerful reminder that the best solutions for the future might be found by looking back into the past. We've seen how civilizations conquered mountains and valleys, but what about the places where there is no visible water at all? Imagine living in a scorching desert, where rain is a rarity and rivers are a distant dream. This was the reality for the ancient Persians. They faced the ultimate challenge. How do you create a thriving civilization in a land where water simply doesn't exist on the surface? Their solution was not to bring water from the outside with massive canals, but to find it from within the earth. They didn't build, they dug. They created the Qanat, a vast subterranean network of tunnels that tapped into distant underground water sources and brought life-giving water to the surface, completely hidden from the brutal sun and evaporation. This wasn't just a feat of engineering, it was a way of life, a brilliant and courageous act of survival. So, how did they build something so audacious? The process was a meticulous, dangerous, and highly specialized art. It began with the mother well, a deep vertical shaft dug at the foot of a mountain or a high-ground area where a water table was known to exist. This was the water source. From this mother well, the true work began. The builders, known as muqanis, would start digging a long, gently sloping tunnel, sometimes for dozens of kilometers. This required an extraordinary level of skill and precision. The muqanis had to maintain a perfect, almost imperceptible gradient. Just enough for the water to flow by gravity, but not so steep that it caused erosion and tunnel collapse. They worked in near total darkness, using only simple tools and an almost intuitive understanding of geology. To keep the tunnels straight and the workers alive, they would dig vertical access shafts at regular intervals along the route. These shafts served as ventilation points, allowed for the removal of excavated dirt, and most importantly, let them check their alignment and depth. Think about the sheer scale and risk involved. These tunnels could be over 100 feet deep and stretch for over 50 kilometers. The muqanis worked in suffocating heat, constantly facing the risk of a cave-in, a lack of oxygen, or the tunnel being flooded by an unexpected water pocket. It was a testament to their bravery and their engineering brilliance. The Qanat system was a living organism. It required constant maintenance, as tunnels could collapse or get clogged with sediment. The knowledge of building and maintaining these systems was passed down from generation to generation, guarded as a sacred secret. The genius of the Qanat system wasn't just in its construction, it was in its sustainability. By tapping into the water table and keeping the water underground, it minimized evaporation. In a desert environment where every drop counts, this was a game changer. The Qanats allowed for the creation of massive agricultural fields, thriving cities, and a powerful civilization in a region that should, by all accounts, have been uninhabitable. What is most remarkable is their longevity. Thousands of these Qanats are still in use today, a testament to their incredible durability and a powerful lesson in sustainable design. They have survived centuries of political change and environmental shifts, continuing to provide water for people in Iran, Afghanistan, and Oman. In an era where we face global water scarcity and unpredictable climate patterns, the Qanats are more than just historical relics. They are a blueprint for modern solutions. They teach us to look for water where others can't see it, to work with the Earth's natural systems rather than against them, and to build for the long term. The ancient Persians didn't just survive, they thrived by turning a desolate landscape into a vibrant oasis, all thanks to their hidden rivers. We've journeyed through time and across continents, from the bustling heart of Rome to the soaring peaks of the Andes and the desolate deserts of Persia. We've seen three completely different civilizations, each separated by vast distances and eras, but all united by one profound challenge: how to master water. At first glance, their solutions seem worlds apart. The Romans built monumental arches, the Inca carved intricate channels into mountainsides, and the Persians dug vast underground rivers. Yet when you look closer, you see a common thread woven through all their work. They all possessed an intuitive and deep understanding of natural forces. They didn't have advanced scientific instruments or computers, but they had a genius for observation. They understood gravity, pressure, and the hidden lifeblood of the earth. They didn't just build, they solved problems. They didn't just create, they innovated with a respect for the world around them that we often forget in our modern, technological age. These impossible systems aren't just relics of the past. They are living blueprints for our future. They offer us a powerful mirror, reflecting our own modern challenges. Today, we face global water scarcity on a scale that our ancestors never had to imagine. Our climate is changing, our populations are growing, and our aging infrastructure is struggling to keep up. We've become so reliant on pumping stations, dams, and complex treatment plants that we often ignore the simpler, more elegant solutions right in front of us. The Roman siphons remind us that sophisticated problems don't always require complicated machines. They teach us that a deep understanding of physics and a little ingenuity can achieve extraordinary results. The Inca terraces remind us of the power of working with nature, not against it. In an age where we're worried about flash floods and soil erosion, their systems show us how to harness the power of rainwater, to nurture the land instead of destroying it. And the Persian Qanats, perhaps the most profound lesson of all, teach us that the most valuable resource may be hidden in plain sight. They show us how to sustainably manage water in the most hostile environments on Earth, offering a clear path forward for regions struggling with drought. They prove that innovation doesn't have to be loud or flashy. It can be silent, efficient, and built to last for generations. These ancient masters of water didn't just survive, they thrived. Their solutions were sustainable, eco-friendly, and built to last, not just for a decade or a century, but for millennia. They built with the future in mind, a foresight that seems rare today. So, what can we take away from these incredible stories? It's not about abandoning our technology and going back in time. It's about remembering a fundamental truth. The greatest engineering feats are often the simplest ones. It's about looking at our modern problems with ancient eyes. These impossible systems challenge us to think differently about water. They challenge us to build with humility, to respect our planet's resources, and to innovate with sustainability at the core of every decision. The answers to our biggest problems may not be found in the latest scientific breakthrough, but buried beneath the sands of time, waiting to be rediscovered. Let's appreciate the unseen wonders around us and consider how ancient wisdom can inspire our future solutions. We began this journey by questioning the impossible. We've seen how ancient civilizations with nothing more than stone, gravity, and a profound understanding of their world achieved engineering feats that still stand today. From the Roman aqueducts that fed a million-person city to the Inca terraces that tamed mountains and the Persian Qanats that turned deserts into oases, their work was not a fluke. It was the result of incredible ingenuity, patience, and a deep respect for the very forces of nature. And so, as we end this journey, let's consider what we've truly discovered. It's not just about what they built, but why they built it and the wisdom they left behind. These unseen wonders aren't just remnants of a glorious past. They are a challenge to our own assumptions. They remind us that the most brilliant solutions are often the simplest ones, and that true progress isn't about how fast we can build, but how well we can understand our world. So, the next time you see a simple fountain or a small stream, take a moment to consider the thousands of years of human ingenuity that made it possible. We have so much more to learn from the ancient world than we ever imagined. I hope you enjoyed this deep dive into history's forgotten genius. What other, impossible, ancient technologies do you think we've overlooked? Let me know in the comments below, and be sure to subscribe to join us for our next journey into the unseen.